All right, so it's a new unit, and it is called polynomials. What in the heck is a polynomial? Well, I can tell you what a nomial is. It's a term. So if I say like 2x squared plus 6x, that's called a binomial. It's got two terms separated by the plus. You know, you got this term, you got that term. That make sense to you? What if I added another number like plus 8? Then it's not a binomial anymore. What is it? Take a guess. If it's not a binomial, now, come on, you've probably heard of this before, haven't you? Yes. Trinomial, yeah. And usually you don't go past that, even though you could go to quadnomial. Nobody ever does that. All right, so after you go past this, you just say it's a polynomial of whatever degree. So like here's a monster one. 6x to the 7th plus 5x to the 6th plus 3x to the, I'm going to skip a few, 4th plus 2x plus 9. Now can I count and say this is a 1, 2, 3, 4, 5 nomial? No, we don't say 5 nomial. We don't even say quinnomial, even though you could try to fake that. We just say polynomial of degree 7. Do you remember that the degree is the biggest one you have? You don't add them all up. It's just the biggest power that you have. Okay? So this has 1, 2, 3, 4, 5 terms. And the biggest power is a 7, so it's degree 7. And last thought, these little things are called something. It starts with a C. Can anybody name what these, I'm going to circle them. What are those called? Starts with a C. Okay, they're called coefficients. Coefficient. And this last thing is also starts with a C, and it's called a constant. Because 9 is 9. Flat, that's it. You have 9 pizzas, that's all you got. You can't say that it's going to vary because there's no like x here. Okay, so it's not a variable, that's called a constant. Okay, so what are we doing with these things today? We're taking these polynomials and we're basically adding and subtracting them to other polynomials. All right, so first off, this is a pretty normal polynomial. It's got 3, so we call it a trinomial. This one is not a normal polynomial. What's weird about it and makes it not a polynomial? That x is weird. And here's why specifically you can't do that, because here's what it really would be. 3x to the 3rd plus 7x to the negative 1 plus 10. Did you know that this means 7x to the negative 1? You can't have negative powers or the thing isn't a polynomial. Typical test question. They go, is this a polynomial? Explain why or why not. The powers can't be weird. You can't have negative powers. You can't have fraction powers. Okay, so this is no, it's not a poly because it's got a weird power. The powers have to be normal numbers. And how do I say normal numbers? Well, whole numbers. Did you know that whole numbers can't be negative? A lot of people didn't know that. If I say like -3, is that a whole number? They go, yeah, it doesn't have any decimals or fractions, so it's a whole number. Nope. Whole numbers start with 0. 0, 1, 2. So there is a first whole number. 0 is the first whole number. So your powers can be whole numbers. Is that a polynomial? Yeah, I guess I used to say it wrong. I used to think poly meant that it had to have multiple terms. But this is called a monomial. So it's fine. It's a part of the polynomial family. Even though it's only got one term, it's still considered a polynomial.
Was the first one a polynomial?
Yes, the first one was the only one that was a polynomial because its powers were nice whole numbers. If you got whole number powers, then you're a polynomial. You got weird powers like this one where it was a power of -1, or this one where it's a power as a fraction. You got weird powers, you're not polynomial. And a common mistake is to think it has to be multiple terms. Nope, you can have just one term. It's fine. It's still a polynomial. All right. So mono, bi, tri, and then after tri, they just go with polynomial degree 3. Usually that's what you do if you're going to go with poly, is you say what degree it is. All right. This is one thing you can do to a poly. You can stick a number in it. You get how they just want you to put a -2 in? So then it'd just be -2 to the 6th plus 3 times -2 to the 5th minus 5 times -2 to the 2nd plus 4. Now, what did I do every single time? A parentheses. And I'll tell you why. Here's the simplest one of them all. X squared. If I don't use a parenthesis, or if I do, I get a different answer. So if I say x is -2, and if I use a parenthesis, I'd have this. If I don't use a parenthesis, I'd have this. They're different. Which one's right? This one. It comes out to +4. This would come out to -4, and that would be wrong. So whenever you have a variable, use an empty parentheses. Parentheses for an empty variable. Anytime you have a variable, use an empty parentheses. Okay, so what do they mean? If you've got two sets of parentheses and the only thing is between them is a plus, you can drop the parentheses. It's like they're not even there. But if you've got a minus, you got to distribute that negative in. Do you guys remember that? You ring a bell? You remember that? Okay, so I'll give you the simplest problem you could do like that. It'd be like 7 plus 2 with parentheses plus 6 plus 4. Do I really need the parentheses in a problem like this? No. But as soon as I change it to minus, do you get then it matters? So if there's a minus there, it matters now because you're going to distribute it to both parts. Or you're going to do this 6 plus 4 is 10 and then distribute the negative onto the 10. So with a negative, the parentheses matter. If there's no negative, parentheses don't matter. We are almost done, boys and girls. Is this the kind where the parentheses don't matter? Would you agree they don't matter? Yeah. So you just go through and find like terms and you go, okay, these guys are alike. Put them together. And these guys are alike. Put them together. And weirdly, this doesn't have anything like it. It'd be like if you had a little farm going and you had, you know, some tigers and some, I don't know, some lions and a couple of rhinos. Okay, this is like a giraffe. And there isn't any other giraffes to hang out with. You're just a loner. Why don't you just leave it in your answer and you don't put it with anything else? These are both rhinos, so you can say, I got a total of 7 of those. And then this green one would come next because they're the x squareds. You always put them in order. And then these guys can go together because they're like platypuses or whatever. Minus 6x. And then last but not least, I have the plus 3 because it's also a loner. Nothing to put it with. And there's my final answer. Is it a polynomial? Yeah, because it doesn't have weird powers. That's the key. Is it a trinomial? No, if you go above tri, what should you call it? A polynomial of degree what in this case? What degree is it? Focus. Almost done. Yes? Say it. Degree 3. All right. This is a polynomial of degree 3. All right. Now, what if there's a negative in between the two parentheses? That's coming on the next page. These are more complicated, and it's really classic for kids to know that the negative goes here, but then forget to distribute it to the other ones. It has to go here and here. So it changes all the signs in there. And this will become nope, I'm wrong. This will become minus 2x to the third plus 6x squared and minus 5. Take all the signs of these things and you make it opposite day. And then like goes with like. Tigers goes with other tigers. Okay. And these go together. They're both x squareds. Would you please add these all up and get the answer? And in a moment, I'm going to ask you to compare with the kid next to you. See what you get for the final answer for that problem. We're almost done. You can give me just another few minutes of focus. We'll start your homework together and you'll have a ton of work time. You'll probably finish and be able to do whatever you want. It's a rare and precious little blessing. This 3x to the third. Lydia, does it go with something else?
Yeah.
What?
-2x.
And when you put them together, what did you get?
Just 1x cubed.
Do you have to put the 1 in front of it? Correct. All right. Parker, these x squareds here, did they have anything that was like them?
Yeah. The negative. I guess it's more positive.
Uh-huh, yes, because we had to distribute the negative in front. That became a positive 6x squared. Grand total? Minus 3x squared. You are correct, sir. Noah Tyler, can you finish this puppy off? We got our... Yep, we got the 4x. Doesn't that go with anything?
No.
You are correct. And then finish it.
-5.
-5. Is this a polynomial? Yes. It's too big to have a special name like trinomial or binomial or monomial, so we just call it a polynomial of degree... Say it. 3. It's degree 3. All right, last one. Do this one by yourself.
You just take the biggest polynomial.
Yep, the biggest power tells you what degree it is. So try this one. No help from me. Try not to make any putts or mistakes. This might be our fastest lesson of the whole second semester. So I'm almost done here. Does that go with anything? Yeah, it goes with this. And everybody usually remembers to put the negative on this one. So then that one ends up being -3 and +1 makes -2x to the 4th. Raise your hand if you started right. Cool. And then I go to this, and this goes with this, and it'd be very easy right now to make a critical mistake. That is not a negative. Why not? Because there's a negative in the front, right here, that cancels that out, makes that +x to the 3rd, and +9x to the 3rd makes +10x to the 3rd. Then I'll just finish it up quick. -3x and -7x, because the negatives distributes. -10x. And last but not least, a +7 and a +9, because of this negative distributing. 9 and 7, 16. And there it is. Is that a trinomial? No. It's a polynomial of degree 4. All right, cool. You have a worksheet on that. If you would please open it up. I want to shorten it up because from my experience, we oftentimes have a few too many problems and it becomes just like stupid repetition. We decided to do all of them except the last problem. So on today's homework, you can, when you're done, Dropbox it. Everything except the last problem. You may skip the last problem. Okay, that's all I got for you for today.